This engine never died, and that was exactly the problem. Somewhere in a warehouse in South America, right now, a Chrysler engine from the 1960s is running a forklift. In rural Africa, that same engine is pumping water out of the ground. It has been doing this for decades. Nobody is surprised. Nobody is impressed anymore. It is just what that engine does. It runs. And in Detroit, in boardrooms full of men in suits who never once got their hands dirty, that single fact that this engine simply would not stop was the most terrifying thing they had ever built. The Chrysler Slant-Six, the leaning tower of power, born in 1960. Killed not by wear, not by failure, and not by anything mechanical, but by the people who made it, because it worked too well, lasted too long, and cost them too much money by refusing to break. This is that story. To understand the murder, you first have to understand the miracle. 1959. Chrysler's engineers are designing a new compact engine for a new compact car, the Plymouth Valiant. They needed it small. They needed it to fit under a lower hood line. So, they did something simple. They tilted the entire engine block 30 degrees to one side. That tilt was a packaging solution, a trick to steal a few inches of clearance. Nothing more. What it accidentally created was one of the most mechanically sound engine geometries ever bolted into a production automobile. The slant allowed for longer, straighter intake manifolds, the passages that carry the air-fuel mixture into the engine. Longer manifolds meant better airflow, more efficient combustion, and more power from less fuel. The tilt also made room for an oversized water pump, and that water pump meant the engine ran cooler than almost anything else on the road. You could not overheat this engine in normal use. You would have to actively try, but the geometry was only the beginning. The engineers, either out of genuine ambition or spectacular overkill, built this engine's internals like they were preparing for war. The crankshaft, in the early production years, was forged steel, not cast iron, which is what every competitor used because it was cheaper and more than adequate. Forged steel, the kind of bottom end you would find in a performance engine, a racing application, or heavy industrial equipment. And they put it inside a Plymouth Valiant, a family car for ordinary people driving ordinary miles. The block itself used what engineers call a deep skirt design, the iron casting wrapped far down and around the crankshaft like a fist closed around it. This created structural rigidity that absorbed vibration, resisted flex under stress, and made the lower half of the engine essentially a single indestructible unit. The result of all of this, the geometry, the forged crank, the deep skirt block, and the oversized cooling, was an engine that should not have existed in that price bracket. An engine that was, by any honest measurement, wildly overbuilt for the job it was asked to do. And then, there was the oil test. Mechanics began noticing early on that these engines were different. Not just durable in the normal sense, not just it will go a long time if you maintain it. Different in a more fundamental way. So people started testing them, draining the oil completely, then running the engine at full throttle to see how long it would last without lubrication. Most engines seize within 90 seconds. Some do not even make it to 60. The Slant-Six ran for over 30 minutes, wide open, no oil, 30 minutes before it finally gave up. When that result spread through the mechanic community, people did not cheer. They went quiet. Because anyone who understood engines understood what that number meant. It meant the tolerances were so precise, the metallurgy so sound, that the engine could survive conditions that should have been instantly fatal. It meant this was not a normal engine. It meant that if you took reasonable care of this thing, it might genuinely never die. And that quiet realization, spreading from workshop to workshop, from mechanic to mechanic, is what eventually reached the boardrooms of Detroit. By the mid-1960s, the American automobile industry had discovered something uncomfortable. Not a mechanical problem, not a safety issue, not a design flaw. Something far more unsettling than any of those things. They had discovered that their best engineering was their worst business decision. If a customer buys a car with an engine that runs for 500,000 miles without significant failure, that customer buys one car. maybe 2 in a lifetime. But if that same engine begins to show expensive, inconvenient, but not dangerous problems around the 100,000-mile mark, everything changes. The customer comes back for repairs. Repair revenue flows to the dealership. Eventually, the customer decides the repairs are costing more than a new car would, and they buy a new car. This idea had a name by then: planned obsolescence. The deliberate engineering of a product's lifespan to ensure that customers return on a predictable schedule. In the 1960s, it stopped being a theory and became operational policy inside the biggest car companies in the world. And the Slant-Six was the enemy of this policy. Mechanics who worked on these engines started noticing something that should have been good news but felt like a problem. The cars came in for scheduled maintenance. The engine never gave them a reason to open the hood for anything else. No gaskets weeping oil, no bearings knocking, no mysterious sounds. Just a clean, cold-starting, smoothly running engine that did exactly what it was supposed to do and asked for nothing in return. Emissions regulations. The Clean Air Act imposed strict new limits on what could come out of an exhaust pipe. This was a real problem, and reducing vehicle emissions was a legitimate response to it. But watch what Detroit did with the regulations, because the execution tells you everything about the intent. The Slant-Six was a simple, robust engine. Engineers who had worked on it said, clearly and on the record, that the engine could be modified to meet the new emissions standards. It would require investment. It would require development work. But it was not an engineering impossibility. It was a choice. Detroit chose not to make that investment. Engines that required specialized diagnostic equipment to service. Engines that sent the customer back to the dealership because the local independent mechanic no longer had the tools to work on. The regulations did not kill the Slant-Six. They were simply the story told to explain the killing. And while the story was being told, something else was happening, something quieter, slower, and far more deliberate. The materials changed. Through the 1970s, heavy cast iron components began to be replaced with thin wall castings, then aluminum, then plastics. The official explanation was weight reduction. The new engines were lighter. They were also mortal in a way the Slant-Six had refused to be. The timer had been engineered into the machine. And then, almost as if the universe was delivering a final verdict, the architecture of the American automobile itself changed. In 1987, after 27 years in production, the Chrysler Slant-Six was retired from the American market. The engines that left American shores did not end up in junkyards. They found their way into the hands of people in parts of the world where planned obsolescence is not a business strategy. In those places, the Slant-Six found its true home. It powers water pumps. It runs forklifts and farm equipment in places where the nearest mechanic might be 100 miles away. It runs because it was designed by people who had not yet learned that durability was a liability. The Slant-Six became the engine of the people the industry forgot to plan for. When people talk about engines like the Slant-Six or the Ford 300 inline-six, there is always an emotion underneath the fact. And it worked. The Slant-Six was not just an engine. It was the last clear example of what happens when engineers build something to work instead of building something to be replaced. If tomorrow a manufacturer announced a new car, no touchscreen, no subscriptions, no software updates, just an engine built the way the Slant-Six was built, designed to last 500,000 miles without complaint, would you buy it, or have we gone too far down the other road that we cannot find our way back? Tell me about your unkillable engine in the comments, the one that refused to quit. Maybe it is the Slant-Six, maybe it is the Ford 300, or maybe it is a Toyota 22R that has been running since before you were born.